Hey guys, Juan Santos here at the Electrical Apprenticeship Program. I'm going to be making a short video on how to solve for the 12 formulas that derive from Ohm's law and Watt's law. These are formulas that we use in the electrical field to be able to solve for certain characteristics inside of our circuits. So the first thing we have to understand is that these 12 formulas derive from two different laws. First one being Ohm's, second one being Watt's. Okay, so these letters inside these two wheels represent the electrical parameters in the circuits that we calculate. The first one being E, which stands for volts. I stands for amps. R stands for resistance. And then P is power, which is measured in watts. So these four variable letters all represent something different in the circuits that we calculate. E voltage, I amperage, R resistance, and P being power. Okay, so the way this works, we have 12 formulas, 3 E's, 3 I's, 3 R's, and also 3 P's. So depending on what I'm looking for first, I would go to my wheel, and if I'm looking for volts, in this case using Ohm's law, I would cover up the E, and that stands for I times R. So that's one of our first equations. Voltage is equal to the current times the resistance. If I'm looking for current using Ohm's law, it's E divided by R, which stands for the voltage divided by the resistance. And the same thing we do with R. Cover up the R, and it's E divided by I, which is the voltage divided by the current. Okay, so those are the three formulas we can get from Ohm's law, and the other three we can get from Watt's law. So do the same thing. P is equal to I times E. I is equal to P divided by E. And then E is equal to P divided by I. So those are the first 6 that we can get simply from these two laws, Ohm's and Watt's. So the other 6 that we're looking for now come from what these two laws have in common. If you noticed here, we have 2 E's, 2 I's, 2 E's for voltage and 2 I's for current, 2 different formulas that will give you the same thing. So we can create what's known as a mathematical statement. In this case, both of these two formulas equal to E. I times R is equal to P divided by I. So in order to start figuring out the unknown values based on this mathematical statement, one of the first things you should do is probably get rid of this fraction. And the way you do that, since it's being divided by I, you multiply it by I. And whatever you do to one side of the equation, you also have to do it to the other side of the equation. So in this case, on this side of the equation, these two i's cancel out, and we're left with P equals to I times I. Well, that's just I squared times R. Okay, so here's our first equation that's derived from the two different laws, I squared times R. And we'll write that over there. So from this equation, P is equal to I squared times R. We can solve for an I, or we can solve for an R. So whichever one we're looking for, we just have to work with the other variable. So in this case, if I'm looking for R, well, I'm going to divide both sides by I squared. On this side of the equation, the I squares cancel out, and I'm left with R equals to P divided by I squared. I'll write that up here. And we'll take this same equation that we started off with, and equals to P equals to I squared times R. Since we've already solved for P, we've already solved for R. The only thing left to solve for is I. So since this is being multiplied by R, to get rid of the R, you divide by it, and you have to do the same thing to the other side. And I'm left with I squared equals to P divided by R. Well, the opposite of the square is the square root. So in order to get rid of the square, just square root it. And of course, you have to do the same thing to both sides. So now I'm left with I is equal to the square root of P divided by R. And I'll write that up here. Okay, so those are the three formulas that we can get from combining ohms and watts for voltage. We can get these three additional formulas. However, we still have another E, another R, and another P. And those come from what the currents have in common. In this case, it's E divided by R that comes from Ohm's law. And then I is also equal to P divided by E, and that comes from Watt's law. This is a little bit simpler. All we have to do is cross multiplication, and when we cross multiply, we can come up with our new equation. So E times E, well, that's just E squared. And R times P, well, that's just that, R times P. So from this mathematical statement that we've derived from the two different laws, we can come up with our other three formulas. So let's see. E squared is equal to R times P. Do the same thing we did before. To get rid of the square, we have to square root it, and whatever you do to one side, you have to do to the other. So in this case now, E is equal to the square root of R times P. So there's our first formula for voltage that comes from the combining the I's. And we'll take this equation up here. E squared is equal to R times P. And now I'm looking to solve for either the R or the P. So whichever one you're looking for, in this case, let's solve for R. So we're going to divide both sides by P. The P's cancel out. I'm left with R is equal to E squared divided by P. Okay, and there's our second equation. Take this same equation. E squared is equal to R times P. We've already solved for an E. We've already solved for an R. So let's solve for a P. In order to get P by itself, divide by R. And that will cancel out the R's on one side, and you're left with P is equal to E squared divided by R. Okay, and that's how you solve for all 12 formulas in Ohm's law. Hopefully this video can be beneficial to some of the students here at the apprenticeship school, or for anybody that's interested in learning how to solve for all 12 formulas that come in Ohm's law equations. But besides that, that's how you do it, and you have a wonderful day.